All right. Well, thank you for joining us, everyone, this morning. I hope you all are doing well and are safe. I want to start by introducing myself. My name is Julio Contreras. I am the Community Education Specialist with UC Cooperative Extension, and we're really excited to provide this workshop. Thank you all for bearing with the technical difficulties that we're encountering this morning. But we're still here and gonna be having this wonderful workshop with Kristyn Leach. So I want to start off with the land acknowledgement, acknowledging that the land here in the Bay Area where I'm at was Chochenyo speaking territory of the Lishjan village of the Ohlone people. And I think it's important at this critical time with climate change and these devastating fires for us to recognize that we need to all gather together and do a better job of land stewardship and repairing the damage that has been done to the land, as well as to the Ohlone people for the violence and the genocide that was done. And I encourage folks to continue to think about the history and legacy of the land. Personally, here in Albany, where I'm at, there's the Segorte Land Trust that is active with the spokesperson Karina Gold, and I just want all of us to keep that in mind as we proceed with this meeting, as well as with the rest of our weekend. And without further ado, I'll let the rest of the hosts present themselves before I introduce Kristyn Leach to go into her presentation. So Rob Benetton, if you could introduce yourself, please.
Hello. Oh, I'm going to take myself off of the stop video for a hot second. Hi, everybody. Good morning. My name is Rob Benetton. I work with UC Cooperative Extension with the Urban Ag program, and it's a pleasure to host Kristyn Leach, and I'm going to pass the mic to Kamyar.
Good morning, everyone. My name is Kamyar Aram. I am the crop production advisor for the East Bay counties, Contra Costa and Alameda, and started about a year ago. I've maybe met some of you. Really excited to be doing this project with Rob and Julio in the Urban Ag program, as well as with Ben Weiss in the Contra Costa RCD, who I will pass the mic to.
Helps if I unmute myself. Hi, everyone. My name is Ben Weiss, and I'm the Ag Conservation Manager here at Contra Costa Resource Conservation District. I want to welcome you all today to this wonderful webinar we're about to have. If you're interested in anything cover crops, feel free to reach out to me. More than happy to connect you with some more resources so that you can do what Kristyn's going to tell us all about on your own farm or ranch, or I guess on your own farm. With that, I think I'll pass it back to Julio.
Thank you. So we have the wonderful speaker, Kristyn Leach, joining us today. And she is currently running Namu Farm, which is a two-acre land in Winters, California. It's an organic farm that she runs in partnership with Namu Gaji, which is a restaurant in San Francisco. And she grows over 60 to 80 crops each year. And I find it fascinating that she's an avid feed for Korean specialty crops. She is going to be covering cover cropping today for different methods, like the no-till, and is going to be sharing with us her practices that she does on the land. And she also runs a CSA from the products that she produces on her farm, which is called Seed Stewards. And she also has a seed sharing our seed business that she can explain more about. And so without further ado, I'll pass on the mic to Kristyn Leach. Thank you for joining us.
Yeah, thank you, Julio. And thanks everybody for inviting me to participate in this. So yeah, I'm a small farmer up in Winters, and I grow mixed vegetable crops and also commercial seed crops. So I'm excited to talk to you. I love cover cropping. and just want to say, you know, like I was really flattered to invited to participate in this. But just wanted to disclose, you know, like I'm not a researcher and I'm not a scientist, and I didn't go to school to study agriculture. I had my own small farm for the last 10 years and, you know, was working on other kind of small to medium sized vegetable farms for, you know, the 10 years before that, basically. So I have a lot of experience on the labor end, and it was once I started my own farm, I started to geek out about the types of systems that would really suit me as a small farmer. So what I'm going to share is, you know, just kind of the way that I've learned to do things and the things that have helped me, just farm with the type of integrity that I wanted to have. And also, just as Julia was saying, you know, we're at this kind of interesting tipping point right now where we're getting to see this upheaval and the sort of dissolution of a lot of structures that aren't really sustainable. And so, I think that even though maybe the alternate title of my presentation could be unpopular opinions about carbon and nitrogen, that I think that there are some real long-term benefits that would serve us all as small farmers to start thinking about. So we're going to go through just a slideshow that I prepared, and then leave a lot of time for question and answers, just because I'm going to get into some specifics, but I really want everybody to walk away with feeling a real practical sense of what next steps are for this fall, even to start cover cropping in your own spaces. So I'm going to go ahead and share my screen.
Video participants.
Okay, so let's see. So I'm going to focus mostly on cover cropping strategies for low-till or strip-tilled systems, which is what my farm has sort of aspired to do. I've got a good track record of every presentation I've done with a Ursula Le Guin or Octavia Butler quote, and so wanted to just kind of continue that on in just thinking about soil, and really kind of the cornerstone of how I approached thinking about cover cropping was to just kind of think about all the things that it fosters beyond just a better alternative to fallowing land. So I wanted to start with kind of what my principles and aspirations are with starting the farm. And so the first thing was, you know, I was really curious how small diversified vegetable farms could, you know, be more complex in the types of interactions we see, and how could we foster the widest range for the most opportunities for those relationships to take on a more kind of, emergent practice where things become greater than the sum of their parts. And so I thought of cover crop not just as, you know, this kind of transaction where we're able to contribute back the fertility that we're taking out with growing, you know, kind of fertility rich, like extractive annual crops, but how it can be more iterative in the long term by the cover crop strategy that I'll get into. I wanted to think about if our small farms could ecosystem services, even within annual crop production, which sometimes gets a bad rap in terms of just some of the negative outcomes. One of the most important things to me, coming from other types of small organic farms, was I was really curious about how we could eliminate the need for off-farm inputs and how our fertility could be sustained and generative. And that was really inspired by, farming practices from Korea, where I was born, as well as just the type of wisdom that, you know, globally peasants and small scale farmers are really holding. And in terms of just who's really responsible for preserving the amount of biodiversity we have left on this planet, it is due to the wisdom and hard work of peasants around the world. And so I was just curious, how can we apply that wisdom in a commercial production farm, somewhere like this country where we get to benefit from a lot of extraction from other communities in order to sustain our fertility. I wanted to also reduce just the dependence on fossil fuels on my farm. So again, like reducing the amount of inputs that are coming in, all the types of practices that create those types of fertilizer, as well as just the amount of fuel I'm burning by using tractors on my farm or mechanization. And of course, you know, just what does resilience look like in the face of climate chaos? And for me, in this part of the Central Valley, you know, I'm mostly focused on increasing heat and drought tolerance in my crops, and then, you know, tending to soil in a way that really maximizes the little rain we get between, you know, probably 12 and 16 inches of rain throughout the year. So what is the best way through soil building practices to really retain, recharge water sources through building organic matter? So some of just the base questions to kind of think about when you're just exploring what cover crops will suit your system best. Like the things I thought about is, what does my planting season look like? So when do I anticipate terminating that cover crop and planting whatever my you know, primary vegetable crops are? And importantly, like what will soil moisture be like? Because all the different range of cover crops you could grow as a winter, you know, main winter season cover crop have different flowering times, different times where they're switching from vegetative to reproductive modes. And that'll affect, again, that carbon to nitrogen ratio, which will affect what you're trying to accomplish and how to best just maximize getting what you're hoping to out of the cover crop. What are the tools you're going to use? So are you using hand tools? Are you mechanized to any extent? Because that'll affect kind of how you're able to successfully incorporate the cover crop. And then are you planning to incorporate all the biomass as a green manure, or do you plan to want to have some as a surface residue? So for me, when I started my farm and knowing that I wanted to explore, you know, these types of Korean natural farming methods, as well as trying to look at no-till on this scale, I'm going to walk through a couple of like the main key points of what felt like important principles. And then we're going to go through a little bit of the methods of how I decided to enact those principles and what types of ecological collaborations I sought from other actors in my ecosystem. And then we're going to look a little bit at outcomes of just short-term and long-term outcomes. So I mostly want through this for you to have a sense of like, I'm going to give you some things that essentially kind of act as recipes, but we want to spend the bulk of the time really thinking about not just how to replicate those recipes, but really how to understand a little bit more about the nature of all of the things involved in a cover cropping system, and then be able to make informed decisions because we understand better how things work and how they interact, rather than just have you know, a very rote step-by-step sense of what to do. Because, you know, things go wrong, farms are idiosyncratic by nature, and so the more consistent you can be to the way that your system is set up, the better able you'll be to be just nimble in the face of all these challenges, which of course as small farmers, you know, this year proved is more important than ever. So let's see. Oops. So the first biggest thing to me was that my cover crop, because I wasn't going to be tilling and mechanically aggregating the soil, and I wasn't going to be incorporating all of the above ground biomass, I knew that what was going to drive like both me improving my soil structure and providing like a boost of organic matter was going to come from roots. So for me, the root biomass created by all those different plants, both my cover crop and whatever vegetable I'm growing, is going to drive my soil organic matter formation and the stabilization of that organic matter. So as you can see here, this is just some baby grasses. And grasses, just the root biomass is at least equal to, if not, you know, many times greater and more complex than the above ground parts, right? And so grasses are different from a lot of other flowering plants. They're monocots. They have really different pathways for, you know, how they draw carbon out of the atmosphere and how they store it into the soil. So I knew that in order to kind of life being fostered in my soil without tilling in, again, those above ground parts, that grasses were going to be my best friend because their root systems are just really, really amazing and dynamic. And so their root exudates feed soil micro-communities while the grasses are growing. So they're sort of exchanging all of the sort of sugars and photosynthate that they're creating in the parts with soil microbes in exchange for nutrients and water holding capacity. Those roots also help aggregate soil, and it fosters good crumb structure, porosity, and just general structure. So if we look here at this photo, you can just see all of these little pathways when this grass is mowed and as this starts to die back, creates lots of opportunities for a pretty long chain of different microorganisms to kind of kick in at different points and digest the food sources presented, as well as just for a lot of insect maneuvering because of the pathways that are left through this. So again, instead of going through there with a rototiller and having that soil structure held because we've mechanically worked that soil to the kind of structure we want, the structure is just coming from like both the living roots and the roots as they start to decompose. Another outcome of just prioritizing and centering roots is that with less disturbance of root systems in our annual crop production, we can allow for more mycorrhizal partnerships. And so mycorrhizae or endomycorrhizae are these type of fungi that form a symbiotic relationship with plant roots. And they help increase access to water, nutrients, and they convert carbon stored in leaves to stable humic compound. So that's just something that we see as like a big contributor and like a broker of all sorts of nutrients, making nutrients available in ecosystems, you know, in our prairies and in our forests, which are two like really robust ecosystems that generate organic matter void of human intervention into them. So it was really inspired by, yeah, what's the logic of self-sustaining generative ecosystems that are able to thrive without, you know, us asserting our dominance in them. So I have like a little wordy slide here, and this is from some reports to just look at, you know, the specific role that this kind of big hope moonshot of all of this is to think that annual crop production can start acting as carbon sinks, and that we don't have to see carbon sequestration only in the realm of, you know, grazing lands, cattle raising, which a lot of the focus about carbon has been in those realms. But my curiosity was more about how can we grow like really amazing nutrient dense vegetables while still maintaining a sense of being able to pull and store organic carbon. So I'll just read this, and there's the footnotes at the bottom if people want to read more about this. But organic carbon, organic nitrogen, and moisture holding capacity always move together. When levels of soil carbon increase, so too do levels of organic nitrogen and the ability of the soil to infiltrate and store water. So this is just saying, like, we're going to get into it a little bit with surface residue, but even with our roots, like already we're looking at a much higher carbon to nitrogen ratio than you typically see in annual crop production, where many times in the field with a cover crop, you're aiming to kind of land somewhere at around like 12 to 24 to 1. So that's 12 or 24 parts carbon to 1 part nitrogen. And with this, like one, having more grasses growing, and two, the maturity of those grasses when we terminate that cover crop, we're really looking at more of like 45 to 60 parts carbon to 1 part nitrogen. So it's extremely high. And if you think about when you build a compost pile, you're balancing that ratio as well. You think about like, we're essentially trying to compost with all brown material, which of course is going to be really slow, but at the end of it, the type of organic matter is just a lot more stable and less volatile. And it's just gives you a wider threshold of how to capture those positive benefits than with short-term tillage where things are incorporated at a younger phase. So organic carbon holds between 4 and 20 times its own weight in water. And in many environments, moisture availability rather than nutrient availability is the most limiting factor for production. So the carbon conversion efficiency is the percentage of carbon inputs, plant litter, animal manure, root exudates, etc., biologically converted to stable soil carbon. For a range of physical, biological, and chemical reasons, the conversion of carbon inputs into stable carbon is higher for root-derived materials than for above-ground biomass. So that's really important here, of just like looking at what contributes that stable carbon pool in our soils, and root-derived materials, as you'll see, are a much greater contributor. So in an analysis of 10 stable isotope experiments undertaken in the field with roots grown with no soil disturbance, found the stabilization of root-derived carbon range from 18 to 91% with an average of 46%, while the stabilization of carbon derived from above ground biomass ranged from 3 to 17% with an average of 8.3. So overall, about 5 times higher for root-derived carbon than above ground biomass. And this next little addition is just to talk about, with this high carbon to nitrogen ratio, this is where we get a lot of pushback from people, because we tend, especially in organic production, to be really worried about nitrogen and nitrogen availability. And so cover crops really, we just think of them as like the contributor of organic nitrogen in lieu of using synthetic nitrogen fertilizer in conventional systems. But I think there's a case to be made that if you have the ability to stay on a piece of land for the long term, investing in that carbon still will yield kind of a dynamic plant available form of nitrogen. It just takes a little bit more time. But this is from Kristyn Jones, who's a really amazing researcher and agronomist. And she says, one reason root-derived materials make such a positive contribution to stable soil carbon pools is that in addition to providing a carbon source, the rhizosphere supports the free-living nitrogen-fixing bacteria and beneficial fungi essential to stabilization. Stable soil carbon is around 60% carbon and 6 to 8% nitrogen. Ideally, this nitrogen should come from the atmosphere, right? So there's the way that we know legumes are able to fix atmospheric nitrogen through that partnership with rhizobium bacteria. So this is just saying there are other ways for soil to actually like access that atmospheric nitrogen and convert it either into nitrate nitrogen or ammonium, which are both the plant available forms of it. And well aggregated soil is porous and has high rates of gaseous exchange. So as soil carbon levels improve, soil structure improves, and the conditions for associative biological nitrogen fixation are enhanced, creating a positive feedback loop. So sorry for the big word dump there, but I wanted to just provide a little background about really the kind of ecology of how amazing roots are and how important it is that we kind of like leave them in the ground, and that, you know, they're allowed to kind of be digested over this long timeline. So we're leaving the roots in the ground, and we're knowing that that's the driver for our biomass. So what's happening above ground? All the terminated cover crop remains as surface residue for us. So the other great thing about having a grass kind of centered cover crop is that we have all this nice free mulch then, right? So you see all of this straw just left at the base of our young soybean plants, and that just sort of stays there. This is that same soybean patch just about 12 days later. So the mulch just kind of sticks around, keeping the soil surface protected and cool and reducing surface evaporation, which for us is just extremely important. Like, we're not only in a super hot climate where, you know, we get several weeks of triple digit and sometimes over 110-degree days. And we also have a lot of wind, especially in the spring and in the fall. And so by keeping that soil surface covered, it just reduces a lot of potentials for erosion or having like our topsoil be stripped off. So again, we've mowed that cover crop. You see it's dried and it's not being incorporated. That carbon nitrogen ratio and we don't have any moisture, right, which is the limiting factor for a lot of decomposition. So what that means is during our prime growing season, there's slow to no decomposition and also no nutrient immobilization because microbial activity is used to digest rather than, transfer food to our growing plants. So our decomposition is low and slow, and that's kind of the other main principle for our farming system. And all of that straw will most likely start to decompose during the wet months over the course of multiple seasons. And so what this does is fosters a longer relay of microbial activity, and there's more food for more participants, basically. We'll get into this because we're going to show just kind of like the process of growing and incorporating cover crop in a tilled and no-till system. But the main analogy I like to use of kind of how this works is that in a lot of the farming systems that I had kind of grown up in and learned from, it's the feeling of kind of being paycheck to paycheck, where you grow a really lush green cover crop, you take it down and incorporate all of that green matter. It digests, in a number of weeks, and then you're trying to press the wave for the plants at the time when those nutrients are plant available. With this, like we've sort of, we have done something with that high carbon to nitrogen ratio. Decomposition isn't going to be happening leading into us putting summer cover crops, but it happens over this long stretch of time. So it's more like putting, starting a long-term savings account where you can't touch that money, but at the end of it, it's kind of generating more fertility than you're taking out. And so this is the good opportunity for us to wean ourselves off of needing external inputs, because even if in the first year there's a little bit of a withdrawal because we're needing those roots to break down, and the mulch is not going to really break down until year 2 or year 3. By year 2 or year 3, like you have this constant layering of those mulch layers, and it's starting to kind of like just slowly break down. And so you're building topsoil essentially with this kind of those fungal partners acting here each year of those subsequent vetch layers. So the things to consider with our surface residue management is how are we taking it down? Are we mowing it, or are we rolling and crimping it? People like doing some amount of solarization to kind of expedite some of the decomposition process prior to planting into. So how do we effectively terminate the cover crop? And we'll get into some of those details too, but I will say, like in the Northeast and a lot of no-till research, they're really fond of the roller crimper, which just, you can basically roll over your fully grown grass crop, and it'll just kind of create, like a flattened grass carpet. For our conditions, it hasn't really successfully worked to terminate the cover crop, and there's folks in Cape Valley that have been using similar implements. But for me, if you look at our straw, we just use a flail mower basically and chop it into, moderately fine pieces and then let that sit, and it works as good as kind of that bigger implement. So in terms of that, instead of rolling or crimping, if you're mowing, what is the particle size and how does that relate to your timeline for decomposition and digestion, right? So the finer the particles, the more rapidly they're able to be digested. Bigger size of the straw, it's going to take a longer amount of time. So in my first year at our new farm, we had always used sickles and scythes to take down the cover crop. And so we were left with pretty long sheets of that straw to use as mulch. But yeah, at this new farm, we experimented with both using a scythe and then also using the mower, and just found that the mower made the mulch really a lot easier to handle rather than kind of raking around these kind of really large pieces of straw. You also want to look at your irrigation method. So we are only capable of using drip irrigation. And so again, if we used overhead, you might have more interaction of like the soil mixing with some of that straw and starting that decomposition process a little faster, which could have desirable and undesirable outcomes. And then the other reality is like that straw makes a great habitat, which is great for us as like land stewards and, us wanting to foster a place that is habitable for the most amount of, species. But it also, as a commercial farmer, drives you crazy because, voles, lots of small rodents love having that straw protection. And so it's just something to consider that is one of the downsides. But in the long term is also an upside because all of those sort of rodent holes and habitats have also created habitat for us for like seeing a lot more frogs and snakes and beneficial insects on the farm as well. So here are just some, the picture on the left is our grass cover crop when it's first germinating. So you just to show how amazing their root systems are, even just from the get. And the photo on the right is just the following kind of end of summer, early fall. And that's kind of like lifting up that straw layer after the first rain, and then just seeing how that root system has also been colonized by a lot more different types of mycelium, and just what it means to have more opportunities for fungi to live and thrive in our soils, rather than like when we're tilling in that green manure, we're mostly selecting for, first or second succession bacteria that really rapidly digest it, which is good for some of our cash crops, but again, we're looking at a longer window of fertility to manage. And so even though we're saying we have this high carbon to nitrogen ratio, and even though a lot of the legumes that are used in cover crops like peas or bell beans or vetch, by the time we're terminating our cover crop while they're flowering, like most of the nitrogen that has been fixed has been translocated to the above ground parts and isn't of much use to us because that'll sit on the surface. We still grow a diversified blend of cover crop just because every plant species has its own relationship with different soil micropopulations. So they're secreting all their own unique blends of and phenols and acids and plant hormones. And that's just really important, the uniqueness of all of those things and what they contribute into fostering, again, like the most complex sort of soil community as possible. So it's just to say, like, root exudates of living crops is just such a kind of amazing food source for your soil community. So the greater the diversity of plants, the greater the diversity of microbes, and in turn, the more robust your soil ecosystem will be. And I will say one thing to note is that we do grow. So typically our mix is, some years a mix of barley, oats, and 2 kinds of peas and a type of vetch. And then in alternating years, we'll switch out the grass component from barley and oats to like triticale, which is a wheat hybrid, or cereal rye. So every 3 years we rotate who the grass just to minimize some of like the diseases that can build up in the soil with just like repeating just one species of grass. And then we do have those legumes in there, again, just to kind of foster that diversity. But there are reports where common vetch contributes as much nitrogen when left as a surface residue as it does when it's actually incorporated. So we basically, our ratio is 2 parts cereal crop, 2 parts peas, and 1 part vetch. And those things, again, have a kind of staggered time. And they also kind of like can tell you a little bit about what is going on in the soil, because grasses, when there is like, some readily available nitrogen to be trapped from your preceding vegetable crop. So that's the other thing. Cover crops act as a bridge and as a trap and relay crop for a lot of those nutrients as your main crops die back. So when there's a good kind of bump of nitrogen from your preceding crop, like the grasses just have such an advantage over a lot of those legumes, and they'll come up really quick. And as you see in this picture, establish pretty densely. In parts of my field where I've used the exact same blend, but it's a little bit lower in nitrogen of like whatever was there, maybe took out more of it, or it was less successfully relayed. You just see the peas end up being the more dominant thing. And so typically the box on the left is like how I had sort of grown up learning to manage cover crop and how I've done it even at our new farm plot when I first started. So we grow an overwintered cover crop, we mow that crop and immediately incorporate it with a disc, which just kind of shreds up a little bit of the residue and has it make good contact with the soil to facilitate digestion. Then you're gonna wait between 4 and 8 weeks, depending on conditions like moisture, how hot it gets, things like that. 4 to 8 weeks for that material to digest. And again, like we're mowing that cover crop like right as it's initiating flowering to kind of maximize when that nitrogen will be at its peak. And so as it's being digested, what's mostly kicking into gear are, again, like early succession bacteria who love to digest that kind of like sweet and really tender green material. We then list up beds or loosen the ground with a chisel plow, rototill to kind of create, again, that aggregated nice seed bed. And then we make another pass with the tractor to firm and mark the bed. So that's looking at, you know, minimum 4, but probably 5 passes with the tractor, and is a little bit harder because you're working really big swaths of ground at once. And so I think that part of the thing that's hard with that is in the springtime, moisture can be so tricky. So getting in to do all of those tasks in their perfect window just presents a lot of challenges, basically. In our system, the way we do it is we mow the crops much later. So we mow once the cereal crops start, the grain inside is pretty well developed. So again, more carbon. We rip our furrows, which I'll show you the process after this. And then again, we have another 4 to 8 weeks for some of that digestion, for some of the root biomass to break down, for that cover crop to really kind of effectively die back, and to warm the soil, because that's the one hard thing by not kind of really working up every inch of the soil and laying it bare. In the springtime, it just stays a lot cooler, which obviously for us has a lot of benefits, but in lots of other parts of the country is a really undesirable thing. But also our digestion, as I mentioned in a previous slide, we're mostly counting on that digestion to happen over several years. And why that is because, you know, those early succession bacteria will come and digest whatever they can, but like those roots and that crop residue at that point are not like super tender and green. And there's a lot more lignins and cellulose and hemicellulose. And those things require like a number of actors to actually break them down fully. And so it creates like a more complex chain of events, which again diversifies your soil community and also creates like a number of kind of interesting biological interactions. But then we plant right into that. So you see this is kind of cover crop at the stage where we're getting, we will mow that, and that's all our surface residue just kind of laying there. For I think 7 years we did this all by hand. We just kind of would go through with a broad fork and loosen the soil a couple inches, and then with a regular garden hoe, kind of just chop it up to make an area to transplant or seed into. We mechanized that this year just because I'm just getting old and tired, I guess, and just wanted to make it a little bit more appealing to more people. So at first, what we tried to do was use our 2 chisel points that mark our beds, which just are little corn points, and you can see they disturb the soil surface about like 1.5 inches, and probably just about 1 inch wide. So this just kind of breaks the surface of the soil, opening up essentially this little slot. But again, like you can see like this beautiful aggregation, like there's just all this root mass, and the thing that's keeping that sort of, you know, biochemical charge of like creating humus and also holding all of these clumps together, like essentially creating this glue, is all of that root biomass. And so it's been really perfect to like rip this little furrow, and then you can just go in there and basically like squeeze that soil, and it aggregates like so perfectly with very minimal disturbance. So that's really what we're what we're hoping for is just maximizing like how incredibly efficient plants are at doing these jobs that instead we've created like, massive machines to do. Then we went over it with just a ring roller to kind of tamp all of these little particles just back down, refill that furrow, and then kind of just tamp the straw back over it. So that was like, us making 2 passes to get the planting area ready. And so then instead we ended up building our own tractor implement after kind of looking at machinery used primarily in the Midwest for corn and soy, different no-till drills. We needed basically a baby version of that because those implements are designed to plant, 100 rows at once with, a gigantic tractor. And so this is just able to be passively pulled on a tractor that, can be like 30 horsepower basically. So up front, we have 1 chisel shank here with 2 straight sharp coulters on either side. So what this is allowing us to do, the coulters are cutting through our residue so that we're not just raking it around. And then the chisel point is again digging that same little furrow and just breaking the surface. The coulters also act to kind of keep everything in line so soil isn't being tossed out to the sides. And then in the back here, well, in between we have these 2 things here, which are called spider wheels. And those just kind of tumble some of the bigger clods and help break them up. And then at the final step is this little rolling basket. And that will do the final job of like really leveling the ground for the furrow. And again, if there's any kind of larger clods, it kind of just breaks it up. So if anything, it's like that those roots are aggregating themselves. It's really pulling through pretty easily. But any big clods, instead of kind of like chopping at them, it's just kind of this impact that is breaking them up, still around kind of that root mass. So here's what those furrows end up looking like with the straw, again, just kind of pulled right after. So with this, we're able to get our beds ready for planting with one tractor pass, because this implement just kind of does the whole thing from ripping the furrow to leveling it and breaking up any clods. So then you can see this is just transplanting right into that straw and how that looks. So the main thing with this is, again, like it's kind of like a whole system to tweak, but you're trying to time like mostly the most significant thing with like having a really good friable soil for seeding or planting into is really dependent on how you treat and manage like that pre-irrigation. And so that was the main kind of kink to work out. But for me, with some of these furrows, like we pull the furrows all at once when the moisture is just right. So again, we really maximize how kind of nice and friable that soil is. And then we'll just run that irrigation and pre-irrigate a couple of days prior to planting. But then we're able to transplant in, and I wanted to show just a couple of slides because I think people's knee-jerk reaction is to think like, yeah, it's going to immobilize a ton of nutrients. There's not going to be a lot of things available. But some of these slides just track, like for us, this is our kidney crop, and you can see this kind of rate and growth. Basically, this is the day we transplant. This is 1 week later. That's 3 weeks later. And then this is just in kind of its prime canopy. And this is with no addition of compost and no fertilizer. And so it really is just from having that bump of this really long release, like throughout the whole season, like we're not needing to side dress or add any other supplemental fertility, because again, it's just kind of like releasing in these like waves as different microbes start to come online. And then, so just also to show you direct seeded melons and then eggplants. So a range of crops, instead of, I think a lot of times with no-till, we see maybe just like winter squash or corn and soybeans. But there's a lot of diversity of crops that all actually did fine. Yeah, again, with no additional input. So just in the fall, the question of reestablishing the cover crop, we will undersow when our main crop is still standing, but kind of just preceding any sort of fall rain. and then go over again like with the flail mower, and then just have all of that crop residue provide just enough coverage. And then we will go over it with a ring roller to kind of just let that seed settle and have good soil contact. But then you can see this is just coming up again through the prior crop residue. So on the topic of that sort of like relay cropping, I will say economically too, one of the good impacts of this is with some crops, like eggplants for us end up being a really long-lived crop. And you know, we could potentially harvest eggplants through the end of November till frost kills them. And if we needed to totally lay the ground bare to get our fall cover crop in, you always make that choice of when you pull the plug on the rest of your crops. But with this, like by relay cropping and undersowing your cover crop, we can let a lot of standing crops that we want to just, you know, winter kill naturally, stay standing and let that cover crop just kind of come up around it. So you get to kind of just maximize your harvest window a little bit as well. And the other thing I'll say is a lot of our crops, we're focusing on like how to make them as long-lived as possible. And again, that high carbon ratio just ends up providing, again, this pretty long haul for nutrients to become available. So we're getting away with being able to not turn and flip planting areas very often, and just having 1 or 2 successions go in the ground. So I wanted to just cover quickly, because Julio said this hasn't been covered yet, this idea of seasonal niches and summer cover crops. So just going to go through a couple scenarios here. One is that we use wildflower mixes for summer cover crop. Summer cover crops are really hard for us because, again, moisture is the limiting factor. So getting a good stand, we don't really want to use like our irrigation budget to water in a cover crop. So a lot of things just haven't worked well if it takes a lot of irrigation to establish and maintain them. So wildflowers are great because they have a staggered bloom time. So kind of they provide a great bridge of nectar and things for different types of insect populations and birds. They can live on just residual moisture from the rainy season, right? So they're going to get established over the winter and then kind of coast on that moisture that they're able to scavenge and find and bloom in late spring through summer. And they're also well adapted. We can find native wildflower mixes that are really well adapted to our soils. So it also just feels nice to, like, you know, remember the places that we've occupied and some of the plant families that have been here before, and do some nominal amount of tribute to who has been here. So one example of this is we grow corn and adzuki beans together. They're in the ground from April through late October, so we're harvesting those things now. We will undersow wildflower seeds into that standing crop, so we'll just go through after we've harvested, again, preceding the rain. We'll mow the corn and adzuki beans, and that thatch will then cover our wildflower seeds. So that'll start to germinate, you know, through the winter. Then we plant our mustard, and we plant mustard green, we plant mustard greens, which is a seed crop for us. So again, it's a little bit longer because we're maturing the seed, and we plant garlic into that. So planting kind of sulfur heavy crops in this rotation. And the corn is great because it has so much residue and it's really hard to, you know, to manage at the end of the season. So instead we just made use of that, plug the garlic into that mulch and let that sit there. And so, you know, the garlic and the seeds we're not harvesting until about June. And so at that time, like if I were to pull those crops in June and try to establish a summer cover crop, it's just a time of year that's so busy. And it's a time of year where moisture is so scarce because we're irrigating in tons of our prime crops. So the wildflowers are the best option for us in this because they've already established themselves. And as we're pulling the garlic, they're going into bloom and they will kind of just stay there, helping just as the ground is going fallow, contributing still some source of food for other things. Buckwheat is, you know, a really popular summer cover crop. And we use it just as a short-term placeholder and as a green manure. So an example of this is, again, we terminate our winter cover crop. we cut our furrows. And again, we cut all the furrows at the same time because we just want to do it at the exact point that the soil moisture is right to pull that implement through it. And so some things, you know, like you see here, okra, we're not planting until late June. And so that furrow, we don't want it to just totally sit bare from, let's say, end of April until late June. So instead, we can get a good short-term buckwheat crop established that, you know, will mature. We can take it down in 45 to 65 days and incorporate that just with a regular hoe and then plant the okra into that. And so it provides not only just a way to keep the little furrow from being bare, but also just like a little bit of bump of now establishing like a little bit of a green manure to plant our okra into. So that's kind of a good like short-term little window to fill. And then cowpeas are that same kind of seasonal niche for us, but as a late summer cover crop. And these are called quail beans. They're a Korean variety of cowpea, but you know, there's black-eyed peas, lots of other types of crowder peas. But cowpeas are really amazing because, you know, typically I would like a cover crop to me should feel like again, like a gift to the land and something that we're not taking anything from. It's not about us. And cowpeas are sort of dubious in that because we do as the dry bean, but they're so prolific and they put on so much biomass and they're really drought hardy that they will produce dry beans, but they never stop making this like beautiful, lush, just vegetative growth. And so a lot of other bean crops, when they're maturing a bean, like all of those nutrients move from the leaf to the developing embryo. But with this, it's kind of putting on that growth. The indeterminate growth is so strong that it's able to do both. So even though we're harvesting the beans at the point when we want to establish our next crop, there's actually still a lot of matter that will benefit the following fall crop planted. This is fairly straightforward. We can grow something like chrysanthemum, which we're harvesting through June. We can get the cowpeas established in late June, and that'll really just grow until October, take that down, and we can establish something else that really benefit from the nitrogen generated by those cowpeas, you know, anytime between September and December. So again, like something like our Napa cabbage, which, you know, is a little bit more, needs a little more coddling and a little bit more fertility. We're able to just manage that through the crop rotation and through, you know, cowpeas. The whole genus Vigna is really effective converters of nitrogen. So aside from soybean, they're the most effective at nitrogen fixation. So they just make kind of a great dual crop for us. So that is all the stuff that I basically prepared for you guys. And I think now we're just going to have question and answer time for you. And I'm not entirely sure who that guy is, but I just looked up soil memes and it seems pretty entertaining.
Game of Thrones, yeah. That's a funny meme. Thank you so much for the presentation. That was wonderful. I personally learned a lot myself. So I'm sure the participants are also learning a lot. And there's quite a few questions that have came up. So I'll take it from the top. And Bob Nelson's question was, do you have any specific tips for cover cropping in raised beds? And that was actually kind of pretty, the other people have asked similar questions to that for the raised beds.
Yeah, definitely. I've thought about this a lot because from like my own experience with using raised beds and just from other friends who've had questions throughout the years, I still think that, and depending on environment, especially in urban settings, like the mulch is such an attractant to different kinds of pests. So I understand it's not always feasible, but to me, it still is about establishing the cover crop and avoiding the tendency to just kind of pull the cover crop and compost it separately and reapply the compost or something like that. But I think you could still do essentially the same thing of growing a mix of grasses and peas. And even if you wanted to chop in some of that residue at an earlier stage, you know, I think that maintaining that fertility in that raised bed setting is a little bit harder. And And so, yeah, that root biomass, again, I think would still serve to substitute for you needing to continually like, add layers of compost or bring in type of soil mixture for those beds. But I don't know that there's any real difference depending on, I guess the things to consider is like if it's a raised bed that's more kind of on a farm, like a longer, rows that are set in raised beds, or just kind of planter beds in a smaller, tighter space. And then maybe just space becomes the most limiting component of how you kind of just set aside like enough of limited space to cover crop and prioritize that when you're really trying to cram in as much production as possible. And so that for me, it's easy, like on 3 acres, you can really rotate stuff out and have a good mix of things like, growing something and getting some rest. But I know in a smaller space, it's a lot harder to have those like 4 or 5 year rotations, basically.
Yeah. Do you have any particular crops that you think in that smaller kind of environment would grow well and would be easy to handle?
Yeah, I mean, I do still think like barley and oats are pretty lower. They're a little bit lower growing than things like cereal, rye is really fibrous and a little bit harder to take down. So I think if you found a mix that was like barley and oats, yeah, some type of field pea, but all of those things are really easy and like will make you feel like a really great pro using a scythe or a small sickle. And for people in Oakland, like Koreana Plaza, the Korean market, their hardware section, you can buy small sickles for like $5. And that's what we use on the farm as well. You could just kind of really blow through there and get your good workout in the spring. But that same blend, like a mix of, maybe if you went a little lower, like a 20% cereal grass component, and then a higher percentage of peas or vetch, it would be kind of a good blend for fostering that soil and also really easy to manage with hand tools.
Okay, thank you. Yeah, somebody had asked about that, the chop and drop not really working well in a garden box, but I think it's manageable with a sickle or with any other method. So the next question is from Robert Nelson. Has Kristyn ever grown mushrooms in between rows? So that's interesting.
I haven't ever purposely grown mushrooms between rows, but that's a good question because again, like speaking to all these things about fostering more fungal growth, we do end up seeing a lot of mushrooms that end up naturalizing, but none that are really edible. They're just kind of like, small field mushrooms and things like that. But to us, it's still a good sign that, there's the capability for fungi to grow. But it would be like a good experiment. I think it's like so brutally dry up here in the summer. We haven't ever really ventured to torture mushrooms by growing them outside here. But certainly like in the Bay Area, especially if you do have that mulch, like that straw could make a really great host to grow mushrooms in between rows as like a living mulch essentially.
Yeah, that's an interesting question. So another question from Nancy Frischberg is, it sounds like Kristyn is working fields and furrows. What adjustment to the technique, either mix of cover crop or mowing / furrows and raised beds, do we need for our raised beds?
Yeah, I think mostly, I think that it would be minimal tweaking. I think that if anything, like raised beds could benefit a lot from this, just because with that type of drainage, just can something that's well drained, but also like porous enough to like really sponge up the soil in a positive way. So again, I still think that the grasses are still kind of the best option in terms of just just minimizing the need to kind of amend soil that is essentially standing alone and doesn't have as much just depth or contact with lower sort of soil profiles. And I know for a lot of folks in the Bay, like that is a concern, like you want to grow in a specifically raised context and not make contact with soil because of contamination or toxin or heavy metals. but I think that, yeah, if on a raised bed, you still kind of, left those roots intact. Because I think the other thing is like another issue that I do think small farms and urban farms need to think about is just like the water source and how linked that is to like different types of soil microbe, and like the potential issue of like salinity over the years. So again, like it's not to make sound like it's a silver bullet, but like stable soil organic matter is really the most sound strategy to just kind of increase your window of tolerance for all things, whether it's your cash crop to withstand and be resilient, as well as the soil to kind of, like hold moisture in a dry year and also not pool moisture or flood in a wet year. And again, like those grass components are just because the roots are just so different from non-monocut plants, it's just so effective at that. And again, it's also because grasses have a C4 carbon pathway, which just is a much more effective converter of pulling atmospheric carbon out. And so in terms of this question of how we sequester carbon, even in a small raised bed, grasses will help you do that.
Oh, it looks like the video for Kristyn might have gone out, so we'll wait for her to come back in. In the meanwhile, I'm seeing a few questions regarding, oh, hey there.
Oh, hi. I don't know what happened.
Yeah. Yeah, if you could share your screen, that way we could see your contact info, that would be great. And so the questions, I think one from Leslie and Nancy again, regarding weedings and the seed bank. So one is, does your grass cover crop after takedown regrow and start to outcompete your crops?
Yeah, that's a great question. Part of when I was trying this was to actually do exactly that, was to have some of the cover crop naturalize by letting it go to full maturity. And the thing is, it's not competitive. If you think of like it as a weed seed bank in the long term, like sure, like in the fall, it may naturalize and compete with early fall crops. But those grasses, all the grasses you would use in a winter cover crop, have a innate summer dormancy. And so that's been the great thing, is that mulch sits there. It could be, you could run your drip line right over it. Those grasses don't come up until their cues are ready in the fall. And again, like I said, with the relay cropping, at times when it is naturalized, it's really great because one, you don't have to buy cover crop seed every year. And then two, you can really just let that cover crop come up at the tail end of your cash crop, and you don't have to terminate it on your own to establish your cover crop. So you kind of maximize both things, where your harvest window goes several weeks longer than the times where I've just mowed and disked everything in to establish my cover crop. You just always have that heartbreaking moment of like, oh, this crop would probably be harvested for another 6 weeks, but I've got to take it down because I've got to just work those acres all at once. So I would say, like, it's not an agronomic problem. It might be sort of like a knee-jerk psychological one of how we think about weeds, but in some ways it's like a great asset, actually.
Yeah, and I imagine it goes well with your management plan for if you have raised beds, like possibly not doing it on all of them, but specific ones that you want to really build soil in. So you take it bed by bed or case by case.
Yeah, definitely.
So the next question by Nancy is, we grow vegetables and are concerned about weeding or competition for the water in raised beds.
I will say that it's, again, because it's like I only have my experience of seeing this system.
Oops.
It looks like a Wi-Fi issue again. But thank you folks for continuing to put your questions in. We'll wait for Kristyn to join. We're getting a really good conversation and a lot of information. I think what we can learn from Kristyn's approach is how she tries different things, and it's a small farm. And so whatever your growing situation is like. It's important to understand it. Every soil is different depending on what location it is or the history of it. So here we have Kristyn coming to join us again.
Were you saying something, Julio?
Yeah, I was just speaking to folks, but yeah, so that was a question about water competition for whatever cover crop you have. I guess maybe if you want to build that soil moisture and then you're cover cropping and so it's absorbing it. So what would be?
Yeah, definitely. So, I mean, it's a growing crop, so it needs water to grow, right? It's one of the few things like a plant just absolutely needs. So yeah, there is that, like it's taking out and drawing some of the moisture from your wet season. But I think if, again, like you're using cover crop in some ways correctly, like the organic matter it's contributing back is what's creating that really sponge capacity of the soil to hold it. So I think in terms of that trade-off, what it's taking out is definitely like it's contributing back, like, you know, tenfold basically. And especially just if it reduces other things kind of down the line as well. But I think just even like being able to reduce, like we use half of the water we did in the times when we've tilled our beds by doing no-till, just because the straw acts as a mulch. And it just like all of that undisturbed lower soil levels, like just creates perfect kind of percolation and infiltration. So it's like the water that isn't being taken up by your growing crop is just really recharging your aquifer, which just creates a longer window. Yeah, in the long term to create like good solid health in in your watershed basically. And then the weed competition, again, like I don't know if it's because the mulch is so effective at suppressing weeds or if the lack of disturbance is creating less opportunities for weed seed to make its way up to the seed bank. But yeah, like you see like a real kind of good runway of like eliminating more noxious weeds through like minimal disturbance. So even things that we have a problem with still, like morning glory, you know, it just can't take hold the same way because we're not going through there and chopping those rhizomes and things like that. So really pernicious, yeah, perennial weeds, you really minimize their impact. So again, it's not to oversimplify and say, oh, this is just the way that all your problems disappear. But, you know, in a lot of ways, yeah, that to really say that soil organic matter and the more stable that organic matter is really meaningful in terms of, yeah, just keeping that water exactly where it needs to be.
Okay. Along those lines, there's a question by Lacey Uke. And how in the first couple of seasons do you manage for weeds? Is hoeing effective, or are there special tractors implemented that help?
Oh, hi, Lacey. She's my neighbor up here. So you know, I like had heard from like an older Korean farmer when I studied like kind of Korean methods of farming and really connecting with the peasant movement there, that it was just like this imperative, like you need to feed yourself and your community with only a sickle and a hoe. And I just really took that to heart for a long time at the old farm. Like, yeah, this is like about survival and, you know, we're just gonna keep having challenges. So I'm just a fan of like just an old fashioned hoe basically. And so I think the question of weeding like it always ends up coming up because like if you are used to mechanically cultivating, it's like you can't drag, you know, like your sweeps and shovels through there to cultivate and weed on your tractor and get your 3 acres done in a day. But I can go through and spot weed and, you know, get an acre done in half a day basically, because it's just not like that same rate of germination. Like in my beds when it's just bare and irrigating even with just drip, it's like every spot along there where the water spreads is like just tiny weeds. And so we don't have that same like thread stage, like just, you know, prolific weed emergence basically. We'll have weeds come up. We have amaranth and things like that. But for the most part, there's one that's going to survive because there's not like a lot of moisture just being distributed around and the soil's not super loose. So we're confining like both like optimal soil conditions and moisture to this tiny little slot. where we're already transplanting like kind of coddled little baby seedlings in. So they've got such an advantage over anything that could be germinating in a seed bank that taking them out is really pretty quick. Like we can hand pull or just knock it back pretty easily. But I think the other option that we've looked at is, or I think Phil Foster down in the Central Coast does this, where he just adapted a flail mower and took off different levels of flails to fit his bed width. And so then it's kind of like, you know, if for me, from tractor tread, tire tread to tire tread, I'm cutting one furrow, then I can adapt my flail mower to just like leave the flails off to clear that crop and then go through and mow down the rest of it. Or using that same rolling basket that is at the tail end of my tractor implement we use, like a rolling basket to just roll over any emerging weeds and kind of just like toss it out of there. But yeah, I'd say the weed pressure is just a lot less with less disturbance. So.
Wow, so it sounds like a lot of adapting and ingenuity of just finding out what works best for the land and for that specific location.
Yeah, again, and it's just that same thing of like on a small farm, like you have to just understand what informs every decision. And as long as all of those things kind of true up with one another, then it just like kind of makes sense holistically. I think the hard thing is sometimes like people want to just say like, oh, we'll substitute this tractor implement out, or that no-till is about just the absence of tillage, when it's actually just about like a lot of other decisions to kind of make about like how you manage water and seedlings and seeds. So it's not just about like, oh, designing the perfect tool and that's it. It's like a lot of other, unwinding a lot of other kind of assumptions and practices.
Wow. All right. We'll move on to the next question. When you're transplanting into the residue, is it hand transplanted or do you use machinery?
We do hand transplanting, though I do, there is, I think through Illinois Co-op Extension, they had designed a really amazing two-seater type of carousel transplanter that looks like my implement, where it's like some sort of chisel opening up a slot and then two people sitting on the back dropping seedlings down a chute, and then just like two little wheels to kind of close the seam. And so you're able to just do the whole thing in one pass. There's some people like at the design lab at UC Davis has talked about maybe trying to design something like that. But again, like from like fabricating a tool standpoint, like the people who are interested in this is a small population. So there's not like a big rush to try to figure out how to, you know, fabricate the materials to make something like that. But I think there are definitely ways to do it. But we just go through by hand where, you know, we irrigate over the mulch. What's worked for us is like a pre-irrigation flush of like 2 hours on drip and then waiting 3 days and then just planting in with like a hori, like a little Japanese digging knife.
Love
But
the
then I will say too, the great thing is when we irrigate that crop in, like I turn on the water just for about 15 minutes to just settle everything. But the moisture is just, it's retained. Instead of like pre-irrigating and then irrigating, you know, for another like hour to 3 hours to get that transplant really the root zone soaked, you know, we're planting into really optimal moisture and then just a little bit to let everything kind of gel together.
Gotta love the hori-kori knives.
I know.
All right, thank you for that. So I've also been asking about the raised beds, and so there's another question about what about clover as a cover crop? That was asked for raised beds, and I think this one is also just in general asking about. The raised bed one was asking about red clover. What about red clover raised beds?
Yeah, red clover can be a great option. They're talking about red clover as like a summer cover crop.
It didn't specify. So
Okay.
Looking at both options or what you recommend would be best for red clover.
Yeah, like we've used crimson clover in our winter blends and then tried to establish red clover as a living mulch in our pathways, like in between our furrows. for us, the challenge is it just takes sufficient water to irrigate it in and maintain it. And so we just haven't used the clover as compared to like the other wildflowers. And like we use cosmos and marigolds, like things that can coast on that residual moisture. But the red clover, I've heard from other people, like if you have cooler conditions and maybe using overhead, then red clover is a great option because it is pretty easy to establish. It's not, you know, as likely to spread through rhizome and become a smother crop for other things, but it really works great as, yeah, a living mulch. But again, like that does get into some of the question of like what someone else referred to is, you know, how much of your budget of both water and nutrient cycling in the soil is going to go, and will those things compete like as kind of essentially companion crops? And so it might take some tinkering to know which crops can grow well with red clover or a clover in the understory, and which things, you know, kind of need a little bit more space. But I would say if you are irrigating it on a small section, on a raised bed, like it would definitely be an easy and good option. Or if you're using overhead, you'd be able to establish it. But if you're in a bigger swath of land and using only drip, I think it's really challenging to get a really even good stand of it.
Okay. Yeah, it seems like it takes a bit more work to establish it. So at a small farm, it seems more, or at a urban ag site, it might be a little bit more easy to manage.
Yeah. I would say too, like I think the crops that get our attention are like, yeah, things like clovers and more the legume things. But just to make a point about the sort of wildflowers and other things as well, like, you know, we have like a beautiful orange cosmos and lots of different kinds of marigolds. And there's just like outside of our thinking about like, yeah, the base NPK nutrients that plants need to thrive. Like there's so many plants that have such unique contributions to the soil. Like, you know, marigolds are a natural nematicide. And so sunlight activates, you know, the ability of their roots to basically inhibit nematodes and things that are really hard for gardeners with certain crops. And cosmos are like a great nectar source for birds and have a really long bloom time. Or like Phacelia we use, and like all borage family crops are dynamic accumulators. And so they're able to really like effectively scavenge nutrients that are usually out of range of like more of our annual crops root systems and bring it up to levels where we can find it. And so a lot of these crops are helping our main crops find, you know, nutrients that are harder to find in plant available forms, whether that's phosphorus, which is more challenging to find organic, like local versions of, or, you know, trace amounts of other types of interesting micronutrients. So again, it's just to say there's lots of stuff that, yeah, in a home garden could really, or in just raised beds, provide like a lot of stacked functions, basically, you know, in terms of just like having a really robust little food situation for all.
Yeah. Okay. Wow. You're very knowledgeable. I really appreciate you answering all these questions. I think we're getting towards our final ones. So we have another questions about the cost, and is it worth fiscally to cover crop?
Yes. So let's see. I cover crop at a pretty heavy rate when I for the winter cover cropping. So I go at like the higher end of the recommended seeding rate at like 150 pounds per acre. So this year I'm cover cropping, I think 6 acres, and it did cost, I think, about $1,300 in seed. Not to mention like the labor. We're like just loading it into a bucket and scattering it by hand. So yeah, there's like the upfront costs. Again, like I think that, so not only in terms of like if you just did it really straightforward and it was just to not have your soil be bare and you incorporated it into your raised beds or tilled it into your farm soil, you know, I think that even just that amount of what it contributes in terms of fertility would be worth it when you look at the cost of, and it may depend, because I know in urban areas, like there are more maybe free sources of compost and different types of food waste, making your own compost. So maybe like adding those amendments is actually cheaper, free, compared to going out and buying and establishing a cover crop. But I think that the net benefits, again, like are just more varied than applying just the straight compost when you look at, effective moisture retention, and just overall, like the habitat that it provides. Because if you left it bare, just like, cropped pretty intensively, just adding compost, I think it doesn't create as robust of a landscape to also provide like habitat for beneficial insects. So you just see less disease and pest pressure. But again, it's cost prohibitive, but I think that, if you think about it as like a return on your investment, it is definitely exceeds it, especially if eventually you can wean yourself off of needing to, use external fertilizer. And for us, like, again, this cover cropping system, like, because it lets us reduce the amount of successions we put in the ground, it just means we're using less seed. We have less inputs in the way of like potting soil or trays or the labor to kind of get those things going. So that's been really helpful too, is again, looking at your economics. Where are the most impactful pressure points of your expenses? I think that you'd find like it's water and fertility management, and all of those things can really be affected in a pretty linear fashion when you just look at the outcomes of cover cropping.
Wow, that's the holistic approach. Looking at the system as a whole. Okay, wow. We have another question. I think you mentioned Federica was your neighbor. So this is specifically winters, California or winter area. How about cover crops for fertility in orchards? What are your recommendations for a mix that would work for the winters area for a stone fruit orchard and citrus orchard?
I mean, that's a good question. I'm like have much less experience with doing cover cropping in orchards, but we are experimenting with a couple different actual like perennial clover mixes to establish in between our stone fruits and in the olives. There's something that actually works really great in terms of the timing, which is like a small Medicago species, like bird's foot trefoil. And so it's a small sort of like sub-alfalfa, and it reseeds and naturalizes pretty readily. It doesn't really kind of get in the way. Like for us, for olives, we're spreading nets on the ground, and so we don't want things growing on the pathway as we're like spreading those nets to harvest. And so those little Medicagos like end up flowering and dying back in kind of a good timely way where it's just using that rain again. But I think for most part, the preferred things for orchards are, those smaller clovers. But certainly I think you can mix in, like we've tried using actually native grasses in between as well, because they're usually a little bit lower growing. Also, so different fescues, bluegrass and things like that. And so, all of those things should be able to be okay with not having supplemental irrigation in the summer. And again, like you could go through, if you have the means to use a tractor, and just kind of roll that down or mow it. And then, all our pathways, we do use small, little micro sprinklers in the apricots. And even with that irrigation, like we don't get a lot of weed competition because, those different grasses stuff again act as a mulch.
All right. Thank you so much. We have a few questions, but we'll see how we can address those. Our time is nearing to the end. We did have a few announcements. I just wanted to give a shout out to your second generation seeds. That's a source that folks can access, and you shared your information earlier. So folks can access this video in our YouTube live channel. I will share that. I think I already have through the emails that I sent out, but that'll be going out again. So one announcement we have is for the next cover crop webinar, which will have Margaret Lloyd talk about cover cropping and annual systems. And then we also have Ben, who is going to be making an announcement about the RCD services. So Ben Wise. at the mic.
Yeah, I was just gonna say, if there was anything that piqued your interest today and you're a Contra Costa resident, feel free to reach out to me at my name, B. Weiss at CCRCD. I'll do you a favor and I'll put it in the chat. We can connect you with people that will help you get cover cropping on your farm or your urban farm or in your raised bed or wherever you would like to do that. Yeah, that's all I had to say, I think.
All right, thank you. And with that, I think we're coming to a close. Thank you so much, Kristyn Leach. This was a really wonderful presentation. I'm sure we all learned so much from your experience and from the challenges, but also ingenuities and different ways of managing the land and working with the land and the plants and the overall system. So thank you so much. We really appreciate it.
Yeah, thanks, Kristyn.
Thank you ever so much, Kristyn. Very grateful to have you. Take care, everybody.
Bye.